In the first experiment, we test two different scheduling strategies and which differ in how they schedule reads on the SSD. So let's contrast these using a diagram. Okay, so first of all, let's explain how reads and writes work on SSDs. A read consists of two components, the actual flash read and the transfer of the page from flash to the controller. A write has the reverse structure, so it first of all consists of the transfer of a page from the controller to flash and then the write of the page on flash. Okay, so in the first scheduling strategy, we try to be greedy in that we try to always schedule we try to minimize latency for reads by always scheduling the transfer of a read immediately after the flash read finished. Whereas in the second strategy, we allow for splitting reads. So we try to be greedy in a different way. Basically, while a flash read is taking place, the read component is not using the channel, and so we try to schedule some operation on a different loon within the same channel to keep the channel busy. Okay, and here is an illustration of basically why the second strategy is better. The second strategy is simply better at keeping the channel busy all the time, and because the channel is a bottleneck to performance, this leads to an overall effect of improving throughput. Okay, so let's verify this using EagleTree. So we have both strategies implemented, and I'm just going to click the run button and test out the first strategy. And now we have results. And before I interpret the results, I should say that the workload we used for this consisted of uniformly distributed reads and writes targeting the entire logical address space. We used these configuration parameters. And we used an initial state of an SSD that was calibrated using the same workload that was used for the experiment. Okay, so here we see that the first strategy, the first greedy and naive strategy, led to a channel utilization of approximately 85%. Which is far from the optimal being 100. And this is a sort of throughput that we were able to get, so approximately 10,000 IOs per second. Okay, let's now try to run the second strategy. Okay, so what we should note is the channel utilization increased to almost 100%, which is a significant improvement, and throughput increased from around 10,000 IOs per second to almost 12,000 IOs per second. Pretty big improvement. Yeah,